All right, in the last video, we talked about the formulas, how you're going to convert a rectangular coordinate xy to a polar coordinate r theta using these formulas. And, there's a little tricky issue with the tangent inverse because it is the functional tangent inverse that gives you quadrant 1 or quadrant 4, which begs the question, how do you get a quadrant 2 angle or a quadrant 3 angle? Well, it needs a little help. They'll be diametrically opposed, 180 degrees away from the actual solution. So when you are dealing with an x-coordinate that is negative, you need to add that 180. And I kind of mentioned offhand what happens if x is 0. Well, if x is 0, you understand this formula is totally out of the question. What you need to do is simply draw the picture out, literally plot the point when your x-coordinate is 0, and then you go from there. You can easily figure it out no matter what the y-coordinate is, positive or negative. All right, so using these formulas, we're going to convert this rectangular xy to polar. So this is x, this is y. We want to go to r theta. So let's start off with our r. This is our first problem. R is equal to, write the formula, x squared plus y squared. It's nothing more than the Pythagorean theorem solved for your hypotenuse, or in our case, the radius of the circle that it's on when we go to polar. So what is our radius? It'll be the square root of -1. Make sure if you're putting this on your calculator that you are using parentheses. Without parentheses, you're going to get something very, very different here. So that's +1, that's 3. So 1 plus 3, well, that's 4. Out of calculator. Square root, don't forget, 2. So the r coordinate is going to be 2. As far as your theta is concerned, as long as your x is not 0, it's going to be tan inverse of some sort. So tan inverse, it goes the y over the x. Tangent inverse of y over x, again, that's opposite, adjacent. And in this case, I do have to add 180 degrees, or pi radians if they want this in radians. Why? Because the x-coordinate is negative. If you think about where this point is located, it's 1 to the left, square root of 3 up, that's about 1.7. So 1 to the left, 1.7 up, that puts you in quadrant 2. No way will tangent inverse give you a quadrant 2 angle answer here. So it needs some help. It's going to be diametrically opposed. So that'll get us the correct one by adding 180. So we'll write tan inverse. The y is the square root of 3. The x is -1. Don't forget the plus 180. So that's tan inverse of negative square root of 3. Again, this is principal values, the functional inverse. So what we're looking at, the calculator spits back -60. It really thinks, okay, quadrant 4 is what we're looking at. No, we are not. We need to go diametrically opposed to that quadrant, which would put us in quadrant 2. So -60 plus 180 is 120. So we can say this in polar would be an r of 2. So circle of radius 2 to the right of the pole, and 120 degrees in the counterclockwise fashion. Or if you're feeling like radians, we can call that 2 pi thirds, just to stay fresh with radians. Right. So it's really not terribly difficult when we do these straightforward formulas. Just kind of watch those x coordinates when you figure out your theta here. Let's try a second one. All right. What do I got for you? How's about 2? If you have 5, -5. What would 5, -5 be in polar coordinates? Okay, let's go right to it. R is equal to the square root of 5 squared, plus, again, use those parentheses. I promise you, without parentheses, your calculator is going to give you a 0 here, because it thinks, oh, -5 squared. That is -25, and technically it is -25. With the parentheses, though, we are squaring the entire y coordinate. So make sure you are careful of those sort of pitfalls. Hopefully that would trigger something in your head that something went wrong there if you got a 0 here. All right, so that's 25, that's 25, that's a grand total of 50. Square root of 50, well, split that up into a 25, largest perfect square, times 2. Old algebra stuff here. We're looking at 5 square root of 2 for our r. Our theta, I'm going to go with the tan inverse of y over x. The reason I'm going to go with tan inverse is because the x is not 0. If the x is 0, you can't use this formula because you will be dividing by 0. So y coordinate is -5, the x coordinate is 5. Y over x, will I be needing a 180 help here? No, I will not be, because my x is positive. It's going to be quadrant 4, which is just fine for tangent inverse. All right, so the tan inverse of -1, that is not quadrantal. That's for cosine and sine inverse. Yeah, that's quadrantal, but not for tangent inverse. Tangent inverse, you are looking at, negative 45 degrees. Quadrant 4. So what is 5, -5? In polar, we would say it's 5 square root of 2, comma, -45 degrees. That would be our r and our theta. All right. Let's try one more, and don't want to spoil this one. Third one. Nothing suspicious here, just another run-of-the-mill problem. Nothing to raise any red flags. Number 3, let's say we had -6, 0. Right, so let's figure out our r. And don't change up a good thing here. -6 squared plus 0 squared. All right, -6 squared is 36. So we're looking at 36 plus 0, or the square root of 36 plus 0, which is square root of 36, or r is 6. Our theta. Now, even though our y coordinate is 0, we're okay. When you do y over x, it's not going to be a problem here. So we'll go with the tangent inverse again. The x coordinate's not 0, so I'm not worried about it. So it's y, 0 over x. Now, keep in mind, you still have to follow the rules. The x is negative, so we do have to have the 180 help, because it will not give us the correct answer. This is thinking, oh, 0 degrees. Oh, it's not 0 degrees. -60 is 180 degrees away from that. That's the idea. So that's 0 plus 180, which puts us at 180. So we're looking at 6, 180 would be the polar equivalent to -60. All right, last one, number 4. If I switch these around, let's say, let's go with the same ordered pair, but reverse the x and y coordinates. If I say 0, 6, or 0, -6, I'm still going to go through the r the same way. That doesn't change. So 0 squared plus -6 squared, which is still the square root of 36, which is still 6. Theta, however, we cannot use inverse tangent. You cannot do this. You cannot say the tangent inverse of y over x. That is bad news. -6 divided by 0 is undefined, so you have to look at this intuitively. If you literally plot on the Cartesian coordinate system the ordered pair x coordinate 0, y coordinate -6. There's 0, -6. You should be able to easily figure out what this angle is. Well, you got a couple options here. Technically, you have infinitely many options here. We can go this way, which would be a positive 270, going counterclockwise, or you can take a shortcut and go clockwise and call it -90, or any coterminal angle with those would work as well. Bottom line is, though, you just cannot use tangent inverse. It doesn't work because you are dividing by 0. So I'm going to pick, I don't know, let's go with 270, just because I like it. So what is 0, -6? Sorry, didn't leave myself room there. 0, -6 would be the ordered pair 6, 270 as an r and a theta in the polar coordinate system. All right, hopefully this helps on Canvas. You should have a PDF for this assignment, as well as the solutions, as well as polar graphing paper. Right? You'll have like 12, 6 on the front, 6 on the back. I think it's in degrees, though it might be both degrees and radians. I totally forgot. So you'll figure it out.